Okay, hi everyone. So in this video we're going to talk about the first 6 exercises of chapter 3, Interdependence and the Gains from Trade. This is a book, Principles of Economics. It's a book of Gregory Mankiw. So the first question says, consider the farmer and the rancher from our example in this chapter. Explain why the farmer's opportunity cost of producing 1 pound of meat is 2 pounds of potatoes. Explain why the rancher's opportunity cost of producing 1 pound of meat is 1/8 pounds of potatoes. So we have to recall this table, which summarizes the hours needed to make 1 pound of meat and 1 pound of potato. In the farmer side, we have that is necessary to have 1 pound of meat 20 hours. For 1 pound of potato 10 hours. On the other side, the rancher needs 1 hour for producing 1 pound of meat and 8 hours for producing 1 pound of potato. So we know when the farmer devotes 20 hours in order to produce 1 pound of meat, in the meantime he can produce 2 pounds of potatoes. Okay, so this is the opportunity cost. What he gives up, in this case 20 hours for 1 pound of meat. In the meantime he can produce 2 pounds of potatoes. In the other side, we have the rancher that devotes 1 hour for producing 1 pound of meat, but in the same time she needs 8 hours for 1 pound of potatoes. Okay, this is 1/8. Okay, so this is what she's giving up, because in this hour she can produce just 1/8 of potato, because she spends 8 hours for 1 pound of potato. So the second one says, Maria can read 20 pages of economics in an hour. She can also read 50 pages of sociology in an hour. She spends 5 hours per day studying. Draw Maria's production possibilities frontier for reading economics and sociology. So we have first here the Maria's production possibilities frontier. So we have in the y-axis we have sociology measured in pages, and we have economics, which is measured in pages as well. We have here, this is the maximum quantity that she can read in 5 hours. So if she devotes 5 hours just reading economics, she can read 100 pages. On the other side, because she reads faster sociology, she can read 250 pages of sociology in 5 hours. These are the extremes values. So the question is, okay, draw the Maria's production possibilities frontier for reading economic and sociology. That's it. The second question B is, what is Maria's opportunity cost of reading 100 pages of sociology? So it takes 2 hours for Maria, because she reads 50 pages by hour. So in 2 hours she will read 100 pages of sociology. But in the meantime she can read 40 pages of economics. Hence, the opportunity cost is 40 pages in economics. The third point, Americans and Japanese workers can each produce 4 cars a year. An American worker can produce 10 tons of grain a year, whereas a Japanese worker can produce 5 tons of grain a year. To keep things simple, assume that each country has 100 million workers. So the first question is, for this situation, construct a table analogous to table 3.1. So this is the table 3.1. We have the time needed to make 1 unit of, and the amount produced in the time established. So here we are talking about years. So given that we are talking about the same inhabitants in each country, I'm going to talk just about per worker. So years needed to make 1 unit of cars. So as we know, United States each worker takes 1 year to produce 4 cars. So it means that the years needed to make 1 unit of cars is 1/4, and each worker produces 10 tons per year. So it means that the years needed to make 1 unit of grain measured in tons is 1/10. In the other side, the same. Japan, each worker produces 4 cars per year. So it means that 1/4 time measured in years is needed to make 1 unit of cars. On the other side, each worker of Japan produces 5 grain of tons per year, which means that is necessary 1/5 years for making 1 unit of grain measured in tons. On the other side, we have the amount produced in 1 year. So in 1 year, either US and Japan, they produce 4 cars each. The other case, grains, US produces each worker 10 tons of grain and 5 tons of grain for Japan. So in order to measure, in order to avoid this fraction, I changed the time to month. I think this first table is okay, but this one is a little bit more understandable because we have here months. So if you divide 12 divided 4, so we have 3. It means that 3 months are necessary for producing 1 car. This is the same result for Japan. And the other side, we have 12 divided 10. It means that 1.2 months are necessary to make 1 unit of ton. 1 ton of grain. In the other side, we have 12 divided 5, so we have 2.4 tons of grain. Months. 2.4 months are necessary to make 1 unit of grain. In the other side, we have the same stuff. Okay, I didn't change anything. So the B point says, graph the production possibilities frontier of the American and Japanese economy. So here is the US production possibilities frontier. So we have in Y, we have the grain, which is measured in millions of tons, because I'm taking account already the 100 millions of people. So we have here the cars. We know that 4 cars are produced by each person, and because there are 100 inhabitants, the maximum production of cars, if United States just devote all his resources, is going to be 400. On the other side, we know that per person, he or she produces 10 tons of grain per year. If we multiply this value for the quantity of workers, there are 100 millions. So it's gonna be 1,000 millions of grains per year. So this is the production possibilities frontier. In the other side, we have the Japan's case. So we have again the same axis, but the cars, okay, still the same because there are 4 cars per worker, and there are 100 million person. In the other side, we have 500. Why? Because each worker produces 5 tons of grain per year times 100 millions. We have as a result the 500 grain measured in millions of tons if all Japan produces just grain. So this is the B. C case, for the United States, what is the opportunity cost of a car of grain? For Japan, what is the opportunity cost of a car of grain? Put information at table analogous to table 3.3. So we have first the United States case. So remember that the US spends 3 months for producing a car. But in these 3 months, they can produce 2.5 tons of grains. Then the opportunity cost is 0.4, which is dividing, which is the division between 2 between 2.5 over 3. Let's see we have here the case. So again, okay, we have this one. The opportunity cost is 0.4 because it's one car divided 2.5. Okay, this is 0.4 because in the time that United States produces just one car, they are giving up the production of 2.5. This is 0.4. If we convert this in a fraction, we have 2 over 5. Why? So remember, we have one car. In the meantime, we can produce 2.5 tons of grain. If we divide, we have 0.4. If we multiply in the numerator and denominator, we have the 4 over 10, and we can simplify by 2, so we have 2 over 5. So this is the opportunity cost. In the other case, we have Japan spends 3 months for producing a car, the same time as United States, but in these 3 months they can produce 1.25 tons of grains. If we divide one car over 1.25 tons of grains, we have the opportunity cost is 0.8, and we can express in fraction as well, 4 over 5. It's the same case. One car, in the meantime, we can produce 1.25. So if we divide, we have 0.8, and we can multiply by 10, we have 8 over 10, and we simplify by 2, we have 4 over 5. So this is the opportunity cost. Now expressing same idea in a table, we have the opportunity cost of one car for United States is 2.5 tons of grains, and the other side for Japan is 1.25 tons of grains. In the opportunity cost of 1 ton of grains is 2 over 5 of a car, and for Japan is 4 over 5 of a car. Okay, the D point says which country has an absolute advantage in producing cars and in producing grain. So we already have this table. Remember, the months needed to make 1 unit of cars and grain. So here, United States, as you see, it has the absolute advantage for grains. Why? Because if you see here, United States for 1 year, he can produce more grain. You see, 10. And what about for cars? So there is no absolute advantage in cars because both either United States and Japan, they can produce the same quantity, 4 cars per year. So absolute advantage in grains for United States. There is a draw between United States and Japan. So the next case says which country has a comparative advantage in producing cars, in producing grains. So we have here the same table that we developed before is about the opportunity cost of United States and Japan. So we have here the products, cars, and ton of grains. So what about here? We see that United States has a comparative advantage in grains. Why? Because if we see grain here, is like the lower cost, okay, is for a car in terms of car. So it's for grains here for United States is the cheapest, okay, between this is the smaller, the lowest. On the other case, we have the Japan. The opportunity cost of producing 1 car for Japan is lower. So in this case, comparative advantage for the United States in grains and comparative advantage in cars for Japan. Question: without trade, half of each country's workers produce cars and half produce grain. What quantities of cars and grain does each country produce? So we have the first case, which is United States production possibilities frontier. So we have the y-axis grain and the x-axis cars. So we have here 400 and 1000, which already we have developed, and if we devoted half of the workers, so we have the 400 divided to 200 and 1000 divided to 500. So this is the point where they produce and consume for the United States case. If we have the other case, we have the same stuff, cars, millions in X axis, and we have the y-axis grain millions of tons. So if we devoted half workers for producing cars and for producing grains, we have this value 200 and 250 for B. So this is the case. So G, starting from a position without trade. Give an example in which trade makes each country better off. So we have again the point that we already had before, A, and the point B for each country. So I propose something, because given the comparative advantage in grain for US, they can just produce grains in exchange of 300 tons instead of 200 cars. You can do whatever you want. I just do this one in order to represent the benefit of trade. So here I'm just specialized US, so I'm going to say to United States, okay, you just like produce grains, which is 1000, and give 300 tons instead of 200 cars. In the other side, Japan can devote all his resources in producing cars, and they can change these 200 cars instead of 3 tons of grains. What is the result that we have? United States produce 1000 and he gives 300 to Japan. Instead, he receives 200 cars. So United States, instead of A, he's going to stay in A star. So we see how they reach an unreachable point that they had before, because it was beyond the production possibility frontier. So this United States, the situation is better. What about Japan? Japan produces 400 cars, but they have to give to United States 200, so they have the 200 for consumption in his country, and the other side, they receive, Japanese people, they receive 300 grains measuring millions of tons. So here we have this part, so they are going to have 300, and we see how they reach a better point. So we have demonstrated how with trade all countries, they are better off. So the next point says, Pat and Chris are roommates. They spend most of their time studying, of course, but they leave some time for their favorite activities, making pizza and brewing root beer. Pat takes 4 hours to brew a gallon of root beer and 2 hours to make a pizza. Chris takes 6 hours to brew a gallon of root beer and 4 hours to make a pizza. So here the first question is, what is each roommate's opportunity cost of making a pizza? Who has the absolute advantage in making pizza? Who has the comparative advantage in making pizza? So we have here summarized all the information in the table. So we have here the hours needed to make 1 unit of pizza and 1 unit of beer measured in gallon. So Pat takes 4 hours for 1 pizza and 2 hours for 1 beer. In the other side we have Chris. She spends 4 hours per pizza, the same as Pat, and she has 6 hours of 6 hours for 1 gallon of beer. So in this case, the first question is, what is each roommate's opportunity of making pizza? So Pat takes 4 hours for producing 1 pizza. In the same time, she can brew 2 gallons of beers. Okay, hence the opportunity cost of 1 pizza is 2 gallons of beer. Okay, and the other side we have Chris. Chris takes 4 hours for producing 1 pizza. In the same time, she can produce just 0.66. What does it mean? Because in this time she takes the 6 hours for 1 beer. Okay, so we are talking about 4 hours, so it will be 4 divided 6, which is 0.66, because in just 4 hours she didn't, or she doesn't finish 1 gallon of beer. She just arrived to 0.66, okay, gallon of beer. Hence, the opportunity cost of one pizza is 0.66 gallons of beer. The second question is, who has the absolute advantage in making pizza? So again, we have here, so who is so who has the absolute advantage in making pizza? So in pizza there is no absolute advantage, because both Pat and Chris, they spend 4 hours for making 1 unit of pizza. So there is no absolute advantage. The second point is, who has the comparative advantage in making pizza? So there is a comparative advantage with the girl that has to give up less for producing pizza. This is the case of Chris. Why? Because her cost, the opportunity cost, is 0.66 as we saw before, compared with Pat. She has an opportunity cost of 2 gallons of beer. So in this case, Chris has the comparative advantage. The C point. The price of pizza can be expressed in terms of gallons of root beer. What is the highest price at which pizza can be traded that would make both roommates better off? What is the lowest price? Explain. So here we have the opportunity cost. So here we have the opportunity cost of 1 pizza, the opportunity cost of 1 gallon of beer for Pat and Chris. For Pat, 1 pizza, the opportunity cost is 2 gallons of beer. And for Chris, 1 pizza, 4/6 gallons of beer. In the other side, 1 gallon of beer is the opposite, is half of pizza, and for 1 gallon of beer is 1 point of pizza. Okay, so given the comparative advantage, Chris will specialize in pizza because he has the comparative advantage, and Pat will specialize in beer. Okay, as we see here, who has the opportunity cost the smaller? Is this one, so Chris pizza, and this one is going to be this one, it's going to be Pat. Okay, so which is the highest price at which pizza can be traded is 2 gallons of beer. Why? Because otherwise Pat, if the price is higher, Pat produce pizza because her cost is lower. So this is going to be the maximum value. Okay, maybe we can put 1 gallon of beer, so both they are going to have like benefits. In the other side, the lowest price of pizza can be traded is 4/6 gallons of beer. Otherwise, Chris will not trade because her opportunity cost is this one, and she is going to trade just if the price is higher. Okay, if you buy 1 stuff for $1, you are not going to sell this for less than this $1. This is not the same case. This is the lowest price. Okay. The fifth point. Suppose that there are 10 million workers in Canada, and that each of these workers can produce either 2 cars or 30 bushels of wheat in a year. So in this case, what is the opportunity cost of producing a car in Canada? What is the opportunity cost of producing a bushel of wheat in Canada? Explain the relationship between the opportunity costs of the 2 goods. So we have the first case. A worker can produce 2 cars in a year, but in the same time he can produce 30 bushels. Hence, the opportunity cost of producing a car is 15 bushels. On the other side, a worker can produce 30 bushels of wheat in a year. In the same time, he can produce 2 bushels. Hence, the opportunity cost of producing a bushel of wheat is 1/15 of a car. So what is the relation between the opportunity cost of these 2 goods? So there is an inverse relationship between both goods. On one hand, the cost of a car is 15 bushels, and the cost of a bushel of wheat is 1/15 of a car. So point, draw Canada's production possibilities frontier. If Canada chooses to consume 10 million of cars, how much wheat can it consume without trade? Label this point of the production on the production possibilities frontier. So we have here the Canada's production possibilities frontier. We have in the y-axis we have the wheat measured in millions of bushels, and we have here the cars measured in millions. So in this case we have remember that we have 10 million people and they can produce 2 cars each worker per year. So we have 20 millions of cars. If Canada devotes all his resources to just cars. In the other side we have wheat. So we have the 30 bushels of wheat per worker times 10 million. So we have 300 millions of bushels wheat if Canada devotes all his production to wheat. So we have here the production possibilities frontier. So here if Canada chooses to consume 10 million, it's going to be 10, which is going to be the divided 20 divided 10, and 300 divided 2, it's going to be 150. So this is going to be the point, okay, that they're going to consume and they're going to produce. The second point, now suppose that the United States offers to buy 10 million of cars from Canada in exchange for 20 bushels of wheat per year. If Canada continues to consume 10 million of cars, how much wheat does this deal allow Canada to consume? Label this point on your diagram. Should Canada accept the deal? So first we have the previous case, okay? This is the original, right? This is the original point without trade. But if they United States is going to buy 10 million of cars, but still Canada consumes other 10 millions, it means that Canada has to produce 20 million of cars. 10 millions for them and 10 millions for the United States. So in this case, this is going to be the consume afterward. They were still consuming 10, and instead of this they're going to receive 20 bushels of wheat per car. So it's going to be 20 per times 10 is going to be 200. So this is going to be the consume of wheat of Canada. So we see here that they change his position from A to A star. So we see how Canada is better off. So in this sense, Canada should accept the deal because the position is better with trade. So they should accept. The sixth and last point, consider a professor who is writing a book. The professor can both write the chapters and gather the needed data faster than anyone else at his university. Still, he pays a student to collect data at the library. Is this sensible? Explain. So first, yes, it's completely sensible. This is due to the opportunity cost. What is the resource limit for the professor? The time. So he cannot do both tasks at the same time. So because of his opportunity cost, so we know that the opportunity cost of the professor for collecting data is higher than the student. So in this case, the professor is going to do what he considers or he thinks and he knows that he is better. In exchange, this time, this opportunity cost, he can put someone with a smaller opportunity cost in order to collect the data, even if he is like slower than the professor because of the opportunity cost. So that's all. That's pretty much all. I hope it has worth for you. Great success with economics. I hope you like it. So see you the next video and thanks so much.